Okay, I think if there's anybody else joining, they can join us as we go along. First of all, thank you very much for making the time available. Um, we will hopefully share some interesting information with you tonight. I have to apologize. It is a fairly technical subject, so I will try and make it as interesting as possible, but unfortunately is a bit dry. That being said, I think it is quite interesting as well. Um, so um, just some general arrangements. You will see that there is a chat as well as a Q&A available. If you have any questions or want to raise any issues, please use the Q&A. We are not going to monitor the chat. Using the Q&A will make it easier for us to actually share the answers afterwards as well. All right, so maybe just a bit of background. I think most of you are familiar with the safety integrity level and everything around that, but there's even after a number of years, and it is now going on almost 10 years since the 62443-3-3 standard has been published. There's still a lot of questions around the security level. All right, so hopefully we will be answering some of the questions around that. Just a bit of information about me. My name is Kobus Poel. For those of you who don't know me, I've got 24 years industry experience, 13 years of which is I've been involved in industrial cybersecurity. I am an ExCo member of the SIIMC, and I'm specifically responsible for the cybersecurity portfolio. I've had quite a bit of diverse training, and I'm currently busy with my PhD in cybersecurity. So to start off, let's try and put the whole issue of SIL versus security level in context. SIL, as I mentioned, has got a long history in the process industry specifically, and especially in high integrity industries like petrochemical, energy in general. It is quite well applied and well used. So it's a mature methodology. It is widely implemented and it is well understood. Now, it must be understood that SIL and security level is not in opposition to each other. Okay, it is complementary. And while SIL is well known, mature, and well understood, security and cybersecurity is less so. It's been a bit of a rocky road for it, and there's not that wide level of acceptance in industry as yet. However, as companies and people start looking at implementing cybersecurity measures, and specifically the ISA or IEC suite of cybersecurity standards, it is quite natural to try and link SIL integrity to security level. And while the two are not equivalent, okay, and it must be very clearly stated, so bit of a spoiler alert, just because you've done a SIL study does not mean that you can reuse the information exactly for the security level study, okay? They are not equivalent, but they are complementary. And SIL cannot be achieved to the expected level without security measures or the security level being achieved. That being said, the SIL can also not be used as a shortcut to achieve the security level. All right. Now, if you look at the diagram on the right-hand side, what I've tried to do there is put it in context. So you have an operation, a plant area, a business that is primarily composed of people and assets. Okay, and to ensure safe operation, you implement HAZOPs and SIL studies, and from there you implemented protection systems, and in this case specifically safety instrumented systems. Now, however, something that is frequently kept out of sight is that the cybersecurity is actually required to meet the SIL requirements. If you look at the latest edition of the IEC 61511 standard, it actually requires you to do cybersecurity implementations as well. Now, what must be understood also is, well, it takes an enormous amount of effort, both in terms of time, cost, to establish the operation, to actually secure the operation and make sure that you can safely operate is orders of magnitude less effort. Okay. And the same applies to determining the cybersecurity and feeding that information into your SIL study. That is, again, probably an order of magnitude less complex and less involved than actually doing a full HAZOP and SIL study. Now, the intention of a safety instrumented system is to reduce risk, and it does that by reducing the likelihood of a risk playing out, as well as the impact. And if the cybersecurity measures are not in place, the safety instrumented system cannot function as designed. So keep that in mind. While it is not equivalent concepts, they are interrelated, and it's important to understand that. All right, so let's just have a quick look at the standards. So if you're looking at SIL, and specifically SIL levels 1 to 4, there's two related standards, the IEC 61508 and the 61511. And SIL and safety related systems deal specifically with predictable and statistical failure. So the intention is to reduce the likelihood of a risk playing out, and essentially you're looking at risk reduction factors. So on the security side, we're looking at the IEC 62443 suite, and there you deal primarily with unpredictable and generally unknown incidents. So it's very difficult to relate statistical analysis to actual likelihood of a security risk playing out. The reason being that the fundamental concepts between SIL and security levels are different. Okay, that being said, the intention of the security level implementations is also to reduce the risk. Okay, it does it in a different manner, but you also have the essentially the cyber risk reduction factor that plays out. So if we look into a bit more depth on the 62443 standard, and the same applies to the SANS version, so the South African version of it, you're looking at 4 overall modules. So module 1 is general concepts and information. Module 2 is security management, and specifically cybersecurity management systems. If you are familiar with ISO 27000, that will be your information security management system, which is not quite equivalent, but it's a similar concept. Then the big one where we are concerned for tonight is the module 3, and specifically 3-3, which looks at system level implementations, and then at the lower level, the component level, is module 4, and essentially for that you don't need to worry too much about. That's primarily for manufacturers. I see we have a few representatives from manufacturers here, so you are probably familiar with that part of the standard. Okay, so it's also important to understand the CIA triad. So that's the confidentiality, integrity, and availability. And it is done in the CIA format when we are looking at primarily standard general purpose systems. Okay. So, however, when we are looking at industrial automation systems, our primary concern is availability, followed by integrity, and lastly, confidentiality. Keeping in mind that you still need to look at maintainability, reliability, and safety. Okay, but reliability and safety plays primarily into integrity as well. Whereas maintainability look mostly at the availability of the system. So how do we relate the CIA or AIC triad to the actual standard? We will go into quite a bit of depth to explain that, but first it is important to understand what security level we are talking about. In the 62443 suite of standards, you are confronted with essentially 4 different security levels. The first one, and the one that we are specifically looking at tonight, is the security level target, which is defined according to 62443-3-3. The others are your security level component, which is, like I mentioned, primarily concerned with module 4 of the standard. And then you have the security development lifecycle assurance, which is, again, primarily focused on manufacturers and their security life cycles. And then for implementers or solution providers, there's something called a maturity level. Now, the intention is that when you define your cybersecurity management system, that you at least look at the relation between the maturity level as well as your security level target to determine the implementability of a solution and by a specific service provider. So I'm just mentioning it. For tonight's presentation, you don't need to worry about anything else except the security level target. So in when defining the target or security level target, you need to understand that there's 7 foundational requirements. Each of these foundational requirements have sub-requirements called security requirements. And then the security requirements are again separated into mandatory requirements and essentially requirement enhancement or optional requirements, depending on the level of the security level target required. So looking at the 7 foundational requirements, we've got identification and authorization control, use control, system integrity, data confidentiality, restricted data flow, timely response to events, and then resource availability. Okay, now when looking at safety instrumented systems or emergency shutdown systems or protection systems, whatever you want to call them, we are looking at only one aspect of the CIA triad, and that is integrity. So for integrity, we are looking at foundational requirement 1, 2, 3, and 6. The others, 4, 5, and 7, are not directly related to safety instrumented systems, but when you implement other solutions that is not specifically related to safety instrumented systems or SIL systems or SIFs, whatever you want to look at, you have to look at the other foundational requirements as well. So keep in mind, I will show this picture again in the next few slides, because it's important to understand that we are looking at 7 or essentially 4 aspects of the 7 foundational requirements. All right. So your safety instrumented level is typically represented by a single number. And let's say in the case of a SIL 3 loop, you have specific requirements around your logic solver, specific instruments, the configuration of the instruments, how it feeds into the logic solver, what your final element looks like, all these kind of things. But essentially every component in that loop relates to the specific SIL required. Now for the security level, generally you also specify that with a single number. However, that actually implies the 7-dimensional vector that we are looking at. So the 7 foundational requirements are then numbered as you see here. Okay, so for security level 1, it's easy. You're looking at security level 1 requirements for each of the foundational requirements. Security level 2, the same, but for a safety instrument system, we're looking at those 4 important aspects that relates to integrity. So your vector looks slightly different. You have the first 3, then you essentially ignore the next 2, and then you have the second to last one. Same applies to security level 3. However, security level 4 is different. The only aspect that is not strictly required for security level 4 is data confidentiality. Okay, and the reason around that is that security level 4 is essentially reserved for nuclear, transportation, and military applications. Okay, so everybody else should never, okay, I can't say never, but you should try and stay away from security level 4 requirements, especially in terms of safety shutdown systems or safety instrumented systems. All right, so keep in mind that while we generally talk about a single figure, we are essentially talking about a 7-dimensional vector when we define a security level. All right, so how does the two relate to each other? Okay, it's easy to say it doesn't, but that's not quite true. Okay, so does SIL 3 imply security level 3? No, because there's not a statistical correlation. While SIL levels are based on statistics and how it relates to each other, security levels are trying to control the unknown. Okay, but generally SIL 1 does imply at least security level 1. The reason being, for a SIL, you would typically expect your system to meet all the 43 base requirements of a security level 1. Okay. However, there are exceptions. And some of these exceptions might be quite critical. Some of it might be for very special applications. Everything in this needs to be evaluated on merit and on its own. So while the SIL does provide you a starting point, it does not provide you with all the details. Okay, so very, very important. There's no one size fits all. You can't assume that for one application you've had a SIL 2 and in that same application the security level played out in a certain manner. Then take that information and apply it to another similar application. Okay, it might be that it's the same, but it might also be very, very different. So you need to evaluate each and every case on its own. It sounds like an enormous amount of effort, and it takes quite a bit of effort, especially the first few implementations. However, once you start getting used to it, once you reach a certain maturity level, it is actually less effort than what a SIL evaluation or SIL calculation would be. All right. So some of the exceptions that you need to look at. And I'm not going to go into too much detail here. It's not super critical to understand this or to know this. It's important to understand that there are exceptions. Okay. So some security requirements, and remember that the security requirements are essentially sub-requirements of the foundational requirements. So under security requirement 1 or foundational requirement 1, you've got a number of requirements. So typically for safety instrumented systems, and I'm not going to go, like I mentioned, in specific detail. I just want to highlight a few issues. Your wireless access, untrustworthy networks, and use control for radio connections. Okay, so in your typical safety instrumented system for the process industry, that's not important. Okay, because you should not have wireless access, you should not have untrustworthy networks or radio connections to safety systems. However, if you look, for instance, at the transportation sector, these things are absolutely critically important for their safety systems. So for those specific cases, you will not be able to ignore these things. You have to look at those and implement it. That's why I say, keep in mind that you need to be aware of the exceptions, but it's not general exceptions. It's specific exceptions based on specific applications. Okay, so those are things that in the process industry you would typically not have to worry about too much. And then there's a number of aspects that is typically already covered by your existing SIL standards. So if you implement your SIL requirements correctly, you don't need to worry about comms integrity or input validation or deterministic outputs or things like that, because it is already covered by your SIL implementation and the associated standard. Okay, so then there's other security requirements that you generally don't need to worry about. Okay, things like confidentiality. We saw that we are more or less ignoring confidentiality for safety instrumented systems. Encryption plays a role sometimes, but only in very special cases. Zone boundary protection, that should not be the case because your safety systems should be in dedicated zones and protected as such. There's certain aspects that cannot be fulfilled by a safety system alone, so you need additional protection anyway. Things like denial of service protection, resource management, things like that. Okay. One interesting aspect, security requirement 7.6, for instance, goes around network and security settings. It's slightly obscure, but it is actually covered by one of the normative references in 61511, which is 61784-3. If you are interested in the technicalities of how the protocols operate and how you secure the protocols, please, it is quite an interesting standard from that point of view, but generally, typically, again, you don't need to worry about it too much. Okay, I'm just going to go back quickly. Just keep in mind that everything that I've said now around safety instrumented systems, and when we think about safety instrumented systems, we think about emergency shutdown devices or things like that. Everything essentially also applies to things like your electrical protection relays, because generally your protection relays form part of either your final elements in a wider SIL setup, or it might actually be a completely self-contained safety system or protection system on its own. So these requirements and these things that I'm highlighting here also applies to your electrical colleagues. So please, if somebody tells you that what you are doing on the instrumentation or control side does not apply to electrical, it's not true. IEC 62443 specifically defines IEDs or protection relays as protection devices. Okay, and the same applies to RTUs. RTUs are not seen as protection devices, but it is seen as a general control element. So again, your safety requirements and safety target levels or security target levels, sorry, will apply to the electrical equipment as well. All right. So just in conclusion, it actually went quite fast. Like I mentioned, SIL 1 does imply security level 1 with noted exceptions. Okay. SIL 2 implies roughly, at least, or approximately your security level 2221121. Okay, as a vector. Okay, with the noted exception and with consideration for special requirements. Okay, keep in mind that you might have a very simple process and might have a repeat of that process and things like that. And you don't need to reconsider your special requirement in each and every case. However, if you do not have repeatable cases like that, please be careful. Consider your actual applications and do the evaluations from there. Okay, then the same applies more or less for SIL 3 as we've mentioned, but you need to be very careful of using false equivalents. Okay, so like I mentioned, SIL and security level or SL is not equivalent. They are related, they are complementary, but they are not equivalent. Okay, your security level study still needs to be done over and above your SIL study. However, your SIL study or a HAZOP does reduce the level of effort, and typically it allows you to spend a bit less effort on the security level. Okay, so the final thing that I just want to mention is what I've explained to you tonight, you won't find in any of the standards. It is implied by the different standards, but it's nowhere does it actually state it categorically and make it clear that you can do this and you cannot do that. Okay, so the reason for that is probably because the relationship between SIL and security level is fairly complex. Okay, so it is not that easy to actually get to a consistent relation. Okay. In some very special cases, there is actually a very close correlation between the two, but that is such a very small percentage of applications that the vast majority of people will probably never run across it. Okay. All right. So let's take a few questions. I see Yihu. What would be the process to reach the correct definition of SIL and security level? Would you start with the initial security level, assess SIL, and iterate between the two to the final state? Yihu, no. So what you would do is you would actually start with the SIL and do your primary assessment based on your SIL requirements. So typically for SIL, you would have your safety aspects. So that would include typical loss of life or injuries, as well as environmental damage. And then lastly, and seen as the lowest priority, you would probably sit with a situation where you have you need to look at equipment and production loss as well. Okay, so on the security level side, you actually have a similar process where you also look at safety, environmental, and then equipment damage or production loss. However, the requirements for the two are significantly different. So essentially what the 61511 standard requires you, and they, when I say 61511, I'm talking about the latest IEC standard, not the latest one implemented in South Africa. We're still running one edition behind. But essentially what it means is you would do everything that standard requires you from a normal process protection perspective. However, to be able to get to a final result, you need to implement the security level requirements and security level protections separately. And then when you do the final assessment, you need to assess both together. So you will start with a SIL, essentially complete the process, and then take that information that will actually help you to do the security level assessment, and then do your implementations and protection from there. Okay, I hope that answers your question. Okay, what should the team composition look like to have a representative assessment? All right. Again, you will have to look at a similar approach to SIL. However, there's a few additional complications. So first off, you will have production representation or process representation. You will have your different disciplines. Okay, that will help you to define what the consequence or impact of the event will be. You would, however, need somebody that is fairly strong in cybersecurity and understands vulnerabilities and problems associated with it, or risks associated with it, to guide and lead the process. Okay. The reason being, like we mentioned, risk is likelihood times impact. The impact is quite easy to determine with let's call it a traditional team. Likelihood is something that is very, very different, especially on the cybersecurity side. So there you would need somebody that is fairly strong. Generally, companies that do not have the expertise bring in facilitators, at least for the first few times. And a lot of companies, especially international companies that we've worked with, use that process to build up their own expertise. And eventually they will be able to take over that role internally themselves. But if you do not have it, to try and do it from scratch without some kind of specialist guidance is very difficult. Okay, does that answer your question? Okay, pleasure. Is there any other questions? Or are you so confused that that you don't want to ask questions?
Cobus, I think we can add on to this that we will make the video available on our Proconics YouTube channel. So if you would like to have a look at it later afterwards, you're more than welcome to.
Yes, yes. Like I mentioned, thank you, Elmarie. The information will be available, and it sometimes takes, especially this is not the easiest of concepts. Sometimes take a few iterations to go through to understand that. Okay. Yes, the process remains the responsibility of the owner. that is 100% correct. So the plant owner, not the solutions provider, takes the responsibility for that. However, very important, if you go look at 62443-2-4, that specifies what the solutions provider must be able to do, and the requirements that must be adhered to from the solutions provider. So yes, the ultimate responsibility is with the owner, but the solution provider needs to provide the service and information and tools to a specific level. Right. So I don't want to go into too much detail around that. If you are interested, you can contact me, and we can have a full discussion around that. It gets quite complex, gets quite technical, but the solutions provider needs to provide services up to a specific level. But you are correct, the ultimate responsibility is with the owner. Okay. If there are no further questions,